Okay, we are back for another live stream here. So again, some reminders with the live stream. If you have any questions along the way, make sure you send them in through the chat. Send them in through send them to me through email or through Edsby, and I'll try and respond to them. I'm keeping tabs on those as we go through the live stream here. So this time we're working with rates and proportion. So I did double up the two sections. So this is the section on rates and the section on proportion. I started looking at our timelines. We're in the middle of May, and we have enough units to go that we need to kind of double up on a couple of these lessons to make sure that all the content is covered by the end of the year. So we'll start with just a quick little review of some of the key terms from this section. So we got ratios, rates, and proportion are the kind of key areas. So previously we looked at ratios. Ratios are comparing quantities of things with the same units. And so when we're comparing things with the same units, what we want is to ensure that we're using the same units, and that when we look at it, things like this, it's going to be 3 cups of water to 1 cup of noodles, and we want to get rid of those units when we actually state the ratio portion. So we're not worried about the units anymore once we get to the actual ratio, because it's 3 cups of water to 1 cup of noodles. It's 3 gallons of water to 1 gallon of noodles. It doesn't matter the actual units in here, so that's why we get rid of them in these cases. In the case of rates, what we're doing is something similar, but we're comparing quantities with different units. So rather than comparing cups to cups, we're comparing cups to tablespoons maybe, or we're comparing, in the example I have here, $20 per 5 kilograms, maybe of, dog food or something. So $20 per 5 kilograms is written like this. We use the slash, or we can write it upright like this. Oftentimes you'll see it like this. But what we can do with rates oftentimes is, instead of comparing using the bump that up, is the so I bumped the audio up here. Hopefully that's a little bit better. Turn it up here too. So hopefully the audio is a little bit better there. I got the audio channel boosted, so you can let me know if that helps. So what were so where was I here? So yeah, so we have $20 per 5 kilograms, but oftentimes we break that down into something more useful, which is the rate per kilogram. So what we can do is we can take the 20 divided by 5 over here, and we get 4. So it becomes $4 per kilogram. That's the unit rate. That unit is usually included when we're working with unit rates. We usually include the units. We don't always have to if it's explicitly known what we're doing. A rate that you might be familiar with is gas, and the gas. When you go buy gas, how much is gas? Well, it's $1.25. Well, you don't have to say the units, but we know it's $1.25 per liter. We don't have to explicitly say that the full set of units in that case. How fast were you going? 100 kilometers. You don't have to say 100 kilometers per hour. So we can often exclude portions of the units if we know the context of what we're talking about. But if we don't, in general, good idea, keep both the units, whatever the top unit is, whatever the bottom unit is, in the rate. And then in the case of proportions, what we're doing there is they're just a comparison of rates or ratios. So here you're going to have an equal sign. So the difference between the three really comes down to, in most cases, you will have no units comparing the same, no units used because they're comparing the same units and ratios. In rates, you're comparing two different units. Oftentimes we'll write that in a fraction type of format like this. And then our proportions are going to be written with an equal sign. So it's going to compare two equal ratios or rates. And that's one of the important things there, is that these are equal to each other. So in this case here, 1/3 equals 2/6, and we know that if we double this rate here, it's going to be 2/6. And the same thing if we wrote it out as in a ratio setup. And then another term that comes up with proportion is the constant of proportionality. So what the constant of proportionality is, and we don't usually use that term a lot, but just that idea of what it is good to know. And that's just how these proportions grow. So this here, it's 1:3, or 1/3. So in this case here, both of these have a setup of 1/3, or you could even write it as a decimal as 0.3 repeating, which is why I wrote 1/3, because the fraction is a little better than the decimal. But it's 1/3 or 0.3 repeating. That's the constant that compares these. So it's 1/3, 2/6, and 3/9, and it would keep moving along that same equivalency. So to get into some of the questions that we have here, what we had was, and let's switch over to that there. In the first section on rates, what we had was that number 1, 2, 3, 4, 5, 6, 9, 11, and 13. And there's probably more questions than we've been used to doing, but most of these are in this new textbook. A lot of these questions are a little simpler in setup, and so they're broken down smaller. They're not multi-part, like it's not one A, B, C, D kind of thing. So a few more to practice, and most of these are pretty quick to do as well. But if we look at the section 1.2 on rates, there's a few questions that I'd like to look at with you guys. Again, if you have specific questions you want me to take up, shoot me an email, shoot me a message on Edsby, shoot me a message in the live stream. You can even do it again before the live stream takes place, and I can do setup on that. Or again, if something comes up where it's after the live stream, you're like, well, you didn't take up this question. You didn't take up question number 5. Could you do that one with me? And I can make a little video, or I can help you out with that. So don't be afraid to ask those questions. So looking at this section here, we're going to go through a few questions. If we look right away at number 1, a 4-liter bag of milk costs $5.50. What is the cost per liter of milk? So looking at that question, we have a 4 liters of milk, and it costs $5.50. And so we want to know the cost per liter. So this isn't laid out right. They gave it to us, 4 liters cost $5.50. We don't want that. We want dollars per liter. So we need this $5.50 to go first. So the cost per 4 liters. So there's the rate. And now what we want to do with this rate is we want to break it down to the cost per individual liter of milk. So how to do that is we take the 550, and this here again is that slash. It's like a fraction. It means divide. We divide 550 by the 4. So $5.50 divided by 4. And when we do that, that is going to give us our unit rate, and in this case, and so we end up getting $1.375 per liter. Oftentimes when we're doing comparisons with unit rates, it's important to leave more decimals, especially in dollar amounts. If you went to the grocery store and were looking at a comparison, oftentimes you'll see these on the price tags of items. You'll see a little, it's so many dollars per 100 grams or per unit. When they have things that come in like multi-packs. Like if you were to go and buy boxes of Kleenex, it might come in. There might be a 2-pack, there might be a 10-pack, and then it compares the prices per box. And so sometimes we want to actually get into more than the regular decimals. Normally we would write this is $1.38 as our cost, but when you're buying things in bulk and when you're looking at these comparisons, sometimes we need to use more decimals. So oftentimes we'll leave a few more decimals here to compare the cost or to use it as a comparison. In this case here, it's probably okay to say $1.37 because we're not doing a comparison. Or sorry, $1.38 as we're not doing a comparison. But again, oftentimes it is important to note that yes, we sometimes get a number of decimals, and those decimals are important to a certain degree in these types of questions. So that's all we're doing though, is that we're making sure things are in the right order to write out the rate, and then we are dividing the top number by the bottom number to actually calculate the unit rate in this case. So this is the rate, this here is the unit rate. So a couple more questions here from this section. If we look at a question like number 2, in number 2 we have after a 4-hour steady snowstorm, there are 24 centimeters of snow on the ground. At what hourly rate did the snow fall? So hourly rate did the snow fall, so how much snow fell per hour is what that means. So hourly rate means how much per hour. So we're looking at snow per hour being our end goal here. Well, we know that 24 centimeters per 4 hours was our initial setup. So how do we switch this over to the unit rate per hour? We divide 24 by 4. 24 divided by 4 is going to get us 6. So we have 6 centimeters per hour being our unit rate. That is our hourly rate. Every hour, 6 centimeters of snow fell on average. Looking at a comparison one now. So number 3 here is going to be a comparison type of question. So in number 3, we have Sarah riding down the Rideau Canal, and on Saturday she rides 40 kilometers in 3 hours. On Tuesday she rides 15 kilometers in 1 hour. And the question is, on which day was her average speed greater? How do we know? Well, the best way to compare when these setups is that we have 2 rates here. We have 40 kilometers in 3 hours, and we have 15 kilometers in 1 hour. So if we break these down into unit rates, we can use those unit rates to compare these. And so that's what we're going to do here. The second one is already set up as a unit rate. So if I switch over here, the second one is already in a unit rate setup. This is 15 kilometers per hour. So she's been pedaling down the Rideau Canal here at 15 kilometers an hour. In the first one, though, it's not a unit rate, so we need to convert that to a unit rate. That will allow us to compare these two situations. So we have 40 kilometers divided by our 3 hours to get the unit rate. So we already have one here, and then our 40 divided by 3 is going to be 13.3 repeating, or if you like fractions, 13 1/3 kilometers per hour. So in this case here, the first day, the Saturday, she had a higher average greater speed. So she was faster on Saturday and how do we know? Well, the unit rate is lower. And so this is the same, that concept I was talking about when we're working at a grocery store or something like that. We're comparing prices. This is the same idea. We look at the cost per unit. So in this case, per hour is our unit rate. And in our unit rate here, it's faster speed on the Saturday. Couple more from this section that I want to look at. An actual grocery store question, which is number 9. So if I switch over to that, number 9 here. And so here we have number 9. A grocery store is selling 2 sizes of brown sugar. And that brown sugar costs, for a 500-gram bag, costs $2.20, and then a 2-kilogram bag costs $5.65. So we want to compare these two values. Now there is a slight problem here, and that is that we can get a ratio, but they're not going to be equivalent because we have a 500 grams in the first scenario, but we have 2 kilograms in the second scenario. So what we need to do is convert one of these into either the 500 grams into kilograms, or we have to convert the 2 kilograms into grams. Now, it doesn't matter which way you go. You will end up with smaller dollar values if you go per gram, just because we're going to be dividing by big numbers. We'll be dividing by 500 and by 2,000. If we can go the other way, there is 1,000 grams in a kilogram, so 500 is half a kilogram. So let's convert that way, just to keep the numbers a little bit bigger. So we'll find the price per kilogram. So in the first scenario, our 500 grams, or sorry, we'll start with the dollars. We're looking for dollars per kilogram here. $2.20 per 500 grams. So let's convert this. We have $2.20 per 0.5 kilograms. So now we have this converted to kilograms, similar to the other one. So now we can do our conversion into a unit rate, and we will do $2.20 divided by 0.5. And what we will get is $4.40 per kilogram. So this is our unit rate for the first situation. And then in the case of the second one, it was $5.65 per 2 kilograms. And so what we do is just divide that, 565 divided by 2, and that is going to get us a $2.87.5, I believe. Let me just double check that. 82.5 cents, sorry. $2.82.5 per kilogram. So there's our 2 unit rates. Which is the better deal? It's better to buy the 2 kilogram bag because the unit price is much lower than the 500 gram bag. Now, in a realistic situation in real life, maybe not. Maybe you don't need 2 kilograms of brown sugar, or if it's a perishable product, maybe it's something that's going to go bad. You might not want to buy a lot because it's you don't need it and it's just going to go to waste. But in just brown sugar, I mean, I've had brown sugar for a long time. It doesn't go bad, so I think I would probably buy the 2 kilograms so that I'm paying way less for that one. All right, the last one I want to look at with rates here is number 13, just because that's a little more of a challenging, or more of a challenging question, I guess, for the stuff here. So we have a car using 35 liters of gas to travel 480 kilometers. We want to know what the rate of fuel consumption per liter in liters per kilometer is. And then we want to know the rate of fuel consumption in liters per 100 kilometers. And then we want to know the rate in kilometers per liter. So we have 3 different rates that we're going to calculate here. And then we want to determine which is the easiest way to think about the amount of fuel being used. So let's take a look at this one here. So number 13, we have 34 liters per 480 kilometers. So A was asking for the liters per kilometer. So that simply, we take our liters, divide it by the number of kilometers. So 34 divided by 480, and that is going to give us 0.07083 repeating liters per kilometer. The next case asks us liters per 100 kilometer. So if this is the liters per kilometer, if we multiply the kilometers by 100, we can also multiply the liters by 100. So we can make this an equivalent rate. So we can make this an equivalent rate. We can make this an equivalency because we're multiplying this by 100. So we multiply this by 100 to get the top number there. So if we multiply that by 100, what we get is, moving the decimal place over 1, 2, we got about 7.083 liters per 100 kilometers. And then in the last case, in C, we were asked for the kilometers per liter. So in that case there, we need to take our initial values and flip them around. So we're going to do 480 divided by 34. And we're going to get 14.12 approximately kilometers per liter. So there's the 3 options here. So the last part said, which rate do you think is easier to think about when we're talking about fuel being used? So I think the first one here, this is such a small number. This one's kind of not a very useful one. The 2 most common ones that you will see are these 2. I think either one of these 2 would be a valid answer here. When in some of the newer cars, and if you look at on my odometer when I'm driving, it will give me a regular update on how many kilometers I'm getting per liter. But at the same time, there's also this, depending on if you're traveling with kind of like within the city, this is often the common one. This is the one you would see on a car window a lot of times. In a car advertisement, you might see the miles per gallon using the U.S. standard. So this one's very common when we're like kind of looking at, oh, what's the more fuel efficient car? But this one's a good one too, especially if you're traveling. How many liters per 100 kilometers I'm going to use, which gives you an idea of how much gas you're going to be buying along the way. So that there is our rates, and then I just want to do a quick little look at some of the proportion types questions. So if I switch over here to do some proportion questions, so in our proportion questions, we're doing something similar to what we did from 13A and B, and we're comparing two equal proportions. So in number 1 here, what we have is the situation of 2 lengths of pipe is $17. What is the cost for 12 lengths of pipe? So this is a pretty straightforward type of question. So in 1.3, number 1, and what we have is two, and we'll use 2 pipe are $17. And we want the cost for 12 pipe. So we can set ourselves up a little ratio proportion here. It doesn't matter the order in this case. If we do a ratio or a rate, or sorry, a rate here, we're going to use a rate, but it doesn't matter the order we write these in, as long as we're setting up the equivalency. So we have 2 to $17 equals, and so I'm writing these rates, and I'm writing them stacked like this, and it'll make sense as we do the calculation. So we want the cost for 12 pipes. So the 12 goes on the top. So pipes are on the top of both of these, the number of pipes, 2 pipes, 12 pipes, and then our cost is going to be down here on the bottom. And so we don't know our cost. So we can use a question mark or an X or a happy face, whatever, something to symbolize that we don't know that value. Now, how do we go about calculating this? Well, this is where we use that concept of what's called cross multiplication. So we're going to multiply across the equal sign, and we're going to make a cross in the middle by doing that. So the 17 multiplies across to the top, and the question mark multiplies across to the 2. So we have 2 times our question mark equals 12 times the $17. And we have 2 times our question mark equals, and we calculate that 12 times 17, and that's going to give us 204. So 2 times our missing value is 204. Using that concept of using opposite operations, we're multiplying by 2 over here. We want to get rid of that 2. So we have to divide this side by 2. That'll get rid of the 2. But if we're dividing by 2 on this side, we also have to divide by 2 on this side. And thus, 204 divided by 2 is going to give us 102. So what is the cost for 12 pieces of pipe? It's going to be $102. So that is the general kind of setup for these types of questions. We're only going to do a couple more here. I know this is running a little longer than usual, but we're going to take a look at a straightforward one like number 2, and then a couple of, or 1 or 2 of the hard ones here. So number 2, I switch over. A school board orders wheelchair ramp for the entrance to a school. For safety reasons, the ratio of height to base of the ramp must be 1 to 12. Write a proportion to determine the base if the height is 0.4 meters. So here we're working with a ratio instead of a proportion or a rate like the last one. So what we can do here is set that up. We had our 1 to 12 is what we were given. So that was the height to base of the ramp, and then we want a height of 0.4 meters. So height to base was what we were given. So our height of 0.4, and we are looking for our unknown value here. So we can set this up the same way that we did the previous one, and that is that we can rewrite these ratios as fractions. 1 to 12 equals 0.4 to our unknown value, our question mark. Again, you could use an X here. You can use any symbol you want to represent your unknown value. And then we'll do some cross multiplying. So when we do that cross multiplying, we have 1 times our question mark equals 0.4 times 12. And normally we could get rid of this whole 1 because anything times 1 is itself, but I'm going to leave it just to show the concept of how this is working. But we have 0.4 times 12, which is going to give us 4.8. And so now we got to divide this side by 1 to get rid of the 1, divide this side by 1, and what we're left with is that the length of our ramp should be 4.8 meters. So that's the general setup of these, is that you set up your ratios or your rates in fractions, and then you cross multiply by multiplying the bottom of each fraction by the top of the other side. Once you've done that, you take the number that is with the unknown value and divide it on the other side, and you'll get your result. So the same process works through each question. Just looking for the last question that I want to do here. I believe I assigned number 16. Yeah, number 16. So we're going to take a look at number 16 here. Little bit of a more in-depth question with this. I'll go down to it. Here we go. So I got Zainab's fish tank holding 75 liters of water, and requires 10 milliliters of water conditioner. The water conditioner removes chlorines and other toxins from the tap water. So the first thing we want to do here is determine that constant of proportionality. We want to know how these are related to each other. So what we need to do is determine what number we would multiply something by to get the amount of the other. And the way we do this, and I'm going to actually pull out my my bottle of, I got some liquid plant food here. So this is like some Miracle Grow. Let's see if I can get that. There we go. So this is some Miracle Grow stuff that I have. And if I look here, probably better if I look at the bottom here where it actually has some comparisons. When I'm using this for houseplants, I want to use 2 milliliters of this stuff per gallon for weekly watering. So the amount of the plant food to the amount of water that I'm adding to my plants is the rate that they're setting up here. And so in our scenario, I didn't even show that, did I? Sorry. Forgot to switch it over. Here we go. Okay, try that again. There's my plant food. So there's my comparison. My half a capful or 2 milliliters per gallon for weekly watering. So this here is the comparison that they use. So they use this material to the water, and so if we compare that to the situation we have in the book here, we're putting conditioner in the water. The amount of conditioner we use is going to depend on the amount of water we use. So that means we want the conditioner to be the first thing because it depends on the water. So if I set this up to find our constant of proportionality, we have 10 milliliters of conditioner and equals 75 liters of water. And so here we have ourselves a comparison of two different units, so we're going to use the rate instead of the ratio setup. And so to find that constant proportionality, how are these related? All we're going to do is find the unit rate. If we find the unit rate, that's the constant proportionality. So we take the top number of 10. This is part A. We do 10 divided by 75, and what we get is 0.13 repeating, as our constant of proportionality. We could also write this as a fraction and have 10 over 75. That would be perfectly allowed as well. But whatever amount of water we put in 0.13, repeating, milliliters of the water conditioner. So if we look at part B now, to finish part A, what does it represent? Well, that's what it represents, is the amount of conditioner that we put in per liter of water. So in part B, Zainab needs to add 45 liters of water to the fish tank, and we want to determine how much conditioner she needs to use before she puts the water in. So all we need to do there is, this is the amount of conditioner per liter of water. So 0.13 per liter. So, and that's we can even say that's per 1 liter. And so we want to know how much conditioner per 45 liters. So there's our setup. All we're doing here, 0.13 over 1 equals the amount of conditioner over 45. And again, with the 1 here, we can almost disregard it. So I'll show you a shortcut here. In the last one, we had the 1 on the bottom. We didn't need to actually work with 1 because it's 0.13 divided by 1 is just 0.13. We could just do a half the cross multiplication. In the case and this only works when the 1's on the bottom. Doesn't work in any other case. If the 1's on the bottom, you can just multiply 0.13 times 45. So that's how much per liter. We got 45 liters, and that's going to give us our unknown. 45 times 0.13. So we're going to need about 5.85 milliliters of conditioner. And then finally, in part C, she has 5 milliliters of conditioner left in the bottle, and we want to set up a proportion to show how many liters she should use for her fish tank. So in this case here, we have 0.13 to 1 is our rate, our unit rate, and then we had 5 milliliters. So we had 5 milliliters, and we want to know how much water to add. So we just set it up like this. And so now I have 0.13 over 1 equals 5 over our unknown. And so in this case, again, we can kind of disregard that 1 because it's on the bottom, and we're going to just multiply the half cross multiply. So 0.13 times the unknown equals 5, because it would be 5 times 1. So it doesn't really matter. It's going to still be 5. And then how do we get rid of this times 0.13? We divide both sides by 0.13. And when we do that, we get a result of 38.5 when we round. So approximately 38.5 liters of water. So there is number 13. Again, a little bit of a longer video, and I apologize. But again, we got to get through some of these. I want to get through some of these concepts a little quicker, as we have a few. So this doubles up for both rates and for proportions. Again, if you have questions that I didn't take up, or about what I took up, or you have questions that, from another section that you want me to look at, EDSB, email, both work anytime. Send me a message and I can help you out with that. Anyways, that's it for today. We will see you guys again next week. All right, take care.